Hi, it's Anonymous here, and today we're going to be talking about torque. So when you think of torque, you may have heard it from torque from a car, torque from an engine, torque from various things. In general, torque is a twisting force that tends to cause rotation. So say you have a lever. Where there's a pin here at which the lever rotates about. Now that pin is in the center of the point of rotation, of course, and we apply a force here, denoted as force F. Now, that force F is a distance r away. Torque will then be equal to r perpendicular times F. Whenever we look at calculate torque, we always want to look at the perpendicular component between R and F. For example, say we had that same lever and this time the force is applied at an angle. We'll call this angle theta at distance r away. Now what will happen is that we're only going to look at the perpendicular component of this force. We're only going to look at this component of this force. As you can see here, there's a component I'll denote as x and a component I'll denote as y. We only want to look at the component that is perpendicular to our radius r at which we're applying the force. As you can see, perpendicular. I'll get more into a different type of explanation of torque later, but this can also be denoted as R cross F, which is equal to R F cosine of theta. Because, as you can see here, when theta is equal to 0, meaning the force is exactly perpendicular, we have cosine of 1, cosine of 0 equals 1, and when we have, say, theta that is equal to 90 degrees, meaning the force is exactly down, pointing towards the point of rotation, then, of course, cosine of 90 degrees is 0. But I'll explain more about cross products later. For now, we're talking about torque. So that is the general explanation for what torque is. We always want to look at the point of rotation, the distance away we are from the point of rotation to the force, and how big this radius is. I'm not sure if you've ever used a hammer or a wrench of some kind, but what they call the moment arm is the point at which you're applying the force say we have some sort of hammer. I need to look at what a hammer looks like again. Anyways, the larger this arm is, the easier it will be to impart this force F onto an object. assuming you're hitting it from the handle, of course. And that is simply because we have a larger radius. Now, say we had an even larger radius and we're applying the same force, then the torque would be even greater, which is awesome. So when you look at objects around you, like hammers, wrenches, doorknobs, any case in which you're applying a force will be greatly helped by a larger radius, as long as you want that motion to be circular. So it's been Anonymous, and thank you for watching.